Hi again, everyone. Chris Tisdale here again. Thanks for tuning in. In this presentation, we are going to continue our series of videos on matrices. And in the previous video, we talked about a row echelon form of a matrix. Now, these matrices, these augmented matrices, are helping us to solve systems of linear equations. And row reducing them puts them in a nice format from which we could easily read off the solution or interpret some other properties of solutions. Now, I'm going to go one step further in this video and talk about a reduced row echelon form of a matrix. This is even simpler, a simpler form where we can read off the solutions, for example, to our system. So what is a reduced row echelon form? Well, I'm glad you asked. Here is what we discussed in the previous video. So we had two criteria for row echelon forms. Basically, all the zero rows are at the bottom, and the first entry of every non-zero row is further to the right as you move down the rows. Okay, so what is it with reduced row echelon form? Well, reduced row echelon form is just a row echelon form matrix where the leading entries have a special value, 1, and every leading entry is the only non-zero entry in its column. Okay, now it'll take a while for that to sink in, but this form is even simpler than this form, and it's even easier to determine the solution set to a linear system. Okay, but the best way to have a go at this is, first of all, to understand this, which I've got some examples about, and secondly, to do some more examples. Okay, so let's move this up here and I'll write a few matrices down here. Okay, so let's have a look here. Let's go 1, 0, 0, 1, 6, 4. Now, that is definitely in a row echelon form. Is it reduced row echelon? Okay, every leading entry is 1. That's a leading entry, yep. That's a leading entry, yep. Every leading entry is the only non-zero entry in its column. There's a column, that's the only non-zero entry, that's the only non-zero entry. So yes, that is in reduced row echelon form. Okay, what about something that's not? Let's go with this one, 0, 0, 1, 1, 0, 2. Now, I claim that that's not reduced row echelon form. Why? Because it's not in a row echelon form. Okay? It's not in a row echelon form. Okay? Why? Because you can see here in row 1, that's the leading entry. That's the first non-zero entry. And as we move down our matrix, we have to move to the left to get to the next leading entry. So this is not in, it's not in row echelon form, and therefore it cannot be a reduced row echelon form. Okay, should we look at another one? Let's take a new page. All right, what about this one? 1, 2, 6, 0, 1, 4. Is that in reduced row echelon form? And the answer is no, because you don't have a 0 here. Okay, so this is in reduced echelon form, but not row reduced echelon form. Okay, and let's do one more. Let's do a slightly bigger matrix. Let's go with this one. Okay, let's squeeze that in. Okay, so let's look. First of all, is it in row echelon form? Well, all the 0 rows are at the bottom. That's good. All the leading entries of each row is here and here. And as you go down, you move to the right. So that is in row echelon form. Next question is it in reduced row echelon form? Let's look at this entry. That's the only, every leading entry is a 1, right? And this leading entry is the only non-zero entry in that column, and same with that one. So it's in reduced row echelon form. Okay, so a little bit fiddly. You'll get better as you go along. Okay, the more matrices you look at and you go, oh, is it row echelon form? Is it reduced row echelon form? Let's do an analysis and find out. And the important thing is, especially with this reduced row echelon form, it is brilliant because you can just read off the answers to the problem. Okay, so what we need now, we know row operations. We know that row echelon and reduced row echelon matrices are nice. What we need now is a mechanism to get from a given problem to a row echelon form or a reduced row echelon form. Now, the answer to that is through an algorithm called Gaussian elimination. We'll talk about that in the next presentation. If you have any comments, any questions, put them in the comments section. And thanks for watching, everyone. As always, bye.